Hello and good evening. What I'm doing tonight is I'm looking over the assignments for this module, and I was putting together the homework assignment, and I didn't give you any drawing, and I looked at the quiz, and maybe I shouldn't. Well, there's going to be drawing on it, and you haven't really had any practice with the drawing program that I recall, so I figured I'd better give you some. So I'm going to give you a practice homework problem, and we'll see. I'll give some kind of credit. I'll give you some kind of credit for it because it's going to be a lot of work to learn to do this thing. So you're going to have to draw some structures on the quiz, and so I decided to do this problem for practice. This is 1521. Draw the line bond formula of a triacylglycerol that contains stearic acid and glycerol. Okay, you're going to learn a triacylglycerol is a triester. It's an ester of 3 carboxylic acids, 3 fatty acids, 2 with glycerol, which is a trihydroxy alcohol. So let's just get on with this. Stearic acid is an 18-carbon carboxylic acid. It's saturated, so it's a carboxyl group. You know what that is, and then 17 more carbons. All right, so the way I'm going to do this is I'm going to start with an 18-carbon chain, and I guess I'll start from here. Now, nope. Notice I click on this. I was on the wrong thing, so I'm clicking on that chain molecule. I'm going to start from this end, and I'm going to get to 18 carbons. See, there's 18 carbons. This tells you how long the chain is. But there's a little bit of a quirk in it that you're going to need to know about. I don't think I really need to do anything more further there. So I'm going to do another, actually I'm going to just draw 3 chains. There's a couple different ways of doing this. 18 and 18. Okay, there's our 18 carbons. This carbon is going to be, these carbons are going to carry we're going to call those the acid, the carboxyl group. So we're going to have to do some things with that. What I want to do is just draw the whole skeleton first and then add the double bonds. You'll see what I'm talking about. Start with the oxygen. I'm going to draw a bond from here to oxygen. You notice this is the single bond there. Hover over the carbon, press down. I'm pressing down on the left mouse key, and just drag this thing out. And you see it's going to put in a single bond to oxygen. I'm going to do the same thing here. I'm going to do the same thing here. All right, now we need to get to, now there's going to be double bonds here, and I guess we could put them in now. We put the way you can, one way to do this is take the oxygen, and you notice it's going to put a hydroxyl, it's going to put a hydroxyl there, and it'll put a hydroxyl here, and it's going to put a hydroxyl here, and that looks, yeah. These things, if you space these two close together, it can be a little cluttered, but now you have the single bonds. You go here, go to the double bond, and then hover over the bond and click on it. So what do we have here now? We have 3 stearic acid molecules. Now we've got that. Now we need to put in the glycerol here. So let's do that. You see what I did? I clicked on the carbon. And you see we're going to have a little bit of trouble fitting this together, but we'll manage it. Okay, so now see what I just did? I go onto this oxygen here and just drag a bond over there. Drag a bond over here. And you see we have it. There's your structure. This is not going to look as pretty as this structure as they draw. I'm not really sure how to get these the longer bonds like they do, but at least in this case I managed. But this is one way. This is one way of doing it. That's it. There's our. Let's move this a little bit. You see if I can find a thing to drag. There we go. So there's a structure we have. You notice these lines and these angles don't have to be symmetrical. They don't have to be of equal length. Okay, let's submit this and see what we get. You see it's correct. That's one way of doing it. Let's do it another way. Because here's another thing I want to show you. This program has some quirks. Let's start by drawing the glycerin. Do it the same way. So we're going 3 carbons. Remember, now we single bond. This is a single bond. We start here, click, hold down the left key. There's an oxygen, hold down the left key here, another hydroxyl, hold down the left key here, and another hydroxyl. Now we want to put 18 carbons on. Here is something you have to keep in mind. I got caught on this first time I tried doing this. You want an 18 carbon chain. There's a chain. You click on it. I didn't take it. Okay, you want to see, you see that blue line there? That means it's active. Here's the thing, if you're going to go in this direction, if you're going to start from oxygen, here's what you need to know. You notice there's a little blue circle around oxygen. That's atom 1 in the chain. So when I hold this down, my left mouse key, I hold it down, and I string this thing out, okay, it says 18 atoms. It says 18. That's 18 atoms in the chain. We have to go, now let's just leave it like this for now. Let's count these things up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, we're a carbon short. Let's do that one more time. Let's do it. Okay, let's go from this side. 2, 4, 6, 8, 10, 12, 14, 16, 17. If you do that, and I did, it's going to be marked wrong. All right, so we're going to go back. We're still on the chain. This is atom 1. So we need to add 18 atoms. We need an 18 atom chain counting the oxygen. So we need 19. See? Now let's count the carbons. 2, 4, 6, 8, 10, 12, 14, 16, 18. Looks like we got it right. Now we need 2 more of those. Okay, we're gonna have to do it like this. And another one. Now all we need is carbonyls. Well, remember how we did it the last time. Oxygen. This thing is getting a little unwieldy here. Let me try it like that. You see, this is, I don't know what program they use to draw there's when they give you the correct answer, and maybe I'll do one where I do that. You just have to have the right, 2 things. All you really need is the right connectivity. It doesn't really matter the angle. This is not necessarily going to be, strictly speaking, three-dimensionally sound, all right? And another thing you want to do is you don't want to, if I were to drag this thing over where it like came across here, and then you tried to, that would cause you problems. You want to make sure all of these atoms are free, that they're not too close to anything else. Okay, now we need to put the double bonds in. remember, you hover over the bond to change the type of bond. So you click on that, click on that, click on that. So there you have it. That should give us a correct answer. Looks like it did. Okay, so that is a way you're going to draw triglycerides. There's going to be a few other things that I'm going to have to get to after lecture tomorrow, but I'm going to post some things so you can see this done. It's probably going to be helpful. You're going to need to practice this thing before you start actually working problems. So I'm going to give you a practice assignment to work on. So you'll see. We'll talk more later, and I'll be back in touch. So have a look at this, and maybe you'll be able to play around with it yourself. But we're gonna, like I said, I'm gonna get to more angles on this thing in the near future.